From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show.
My last name is Bobra, B-O-B-R-A, like Cobra.
That's cool.
I don't know if you've heard this, but here at Fragmented, we love CI services, which is why I'm extremely thrilled today to announce a new sponsor that has been on our radar and we have loved for a long time, Bitrise. Bitrise is mobile continuous integration and delivery for your whole team. And one of the things to love with Bitrise is the dozens of integrations that they have. They take a very different approach where you don't actually have to do a lot of scripting yourself. Instead, you can just keep tacking on a whole bunch of these integrations that they already have available. Head on to bitrise.io/integrations and you'll find a page with a whole bunch of integrations. UI testing, emulator testing, Android lint checks, publishing to the Play Store, they got them all. I'll point you to this blog post that they have called Introducing Solid and Snappy Virtual Device Testing for Android. So we care a lot about UI testing, and it looks like Bitrise does too, which is awesome. Head on over to bitrise.io. It's a nice and simple URL, bitrise.io. Many thanks again to Bitrise for sponsoring today's show.
Kaushik, how you been doing, man?
It's been some time, hasn't it?
It has. It's finally warmed up over here on the East Coast. We got out of like a 9-month tundra, so that's good.
Oh, wow. What's the weather like there?
Oh, yesterday it was like 95. It was pretty hot.
Oh, wow. That's actually pretty good.
It was real hot.
Yeah. As I sound a little condescending from my West Coast comfort.
Was it foggy in San Francisco? Oh.
Wow, I see you're going there, huh? It actually is a little foggy, but hey, it's nice. It is. It is what it is. I'll talk to you in like a month or two and we'll see how you're doing then.
True. That's right. So what are we going to talk about today?
All right, so on a previous episode, we actually talked about this different thing called GraphQL, right?
Yeah.
And we talked with Mike about it, about Apollo, the library.
Yeah.
And as we were looking at this, we ran into something interesting as well. And I remembered a DroidconSF talk that I had actually gone to. And this was about something similar, at least I thought it was something similar. So I thought it would be interesting to bring it up on the show. And this is grpc.
Mm-hmm.
Have you worked with grpc before?
Yes, I have worked a little bit with it, protocol buffers and stuff like that at a previous client. Have you worked with it?
I have not worked with it, but I have gone to this amazing talk by someone who was kind enough to come onto the show to talk to us about it a little more. So without further ado, welcome to the show, Sam.
Hi, glad to be here.
Sam, for the folks that aren't familiar with your talk that Kaushik has watched and many others have watched, would you mind explaining who you are, where you work, kind of how you got involved into Android and so forth?
Sure. So my name is Sam, and I'm an engineering manager at a company called VSCO. And I've been there for about 5 years or so. So it's been a little while. And I've probably been developing for Android for maybe a little bit longer than that, maybe 6 years or so. Got into Android sort of at the tail end of when I was in school, working on my first startup. And so right now I work for a company called VSCO.
So what exactly does VSCO do?
Yeah, so VSCO, which is spelled VSCO, we pronounce it VSCO, but you can pronounce it however you want. So we're an art and technology company, and most people know us for our photography app, which is called VSCO. And VSCO has sort of always been known as one of the best photography apps for people who are serious about creating beautiful images with their mobile phone. And I think these days, people are always surprised when they see photos that were edited with VSCO. They say like, oh, wow, I can't believe you took that on an Android phone, for example. And, but these days phone cameras are really, really good, and they're amazing. And it's so important that we're taking photo editing really seriously for people who want to create art with the phone that they have in their pocket.
Are you saying that if I use VSCO, my picture will start looking better than Don's pictures then?
I think that's probably true. I hate to break it to you.
Okay, I'm probably going to jump on that right away then. So I actually did attend your DroidconSF talk, and it was interesting because I think like right from the get-go, you were very clear about saying, before we even get into what gRPC is, let me tell you a story. And you sort of took us, through a transition where you talked about why you needed gRPC, the challenges that you were facing at VSCO. I thought was like very interesting. Was that an intentional sort of style that you noticed?
Yeah. I think my goal was to tell a story. I think when jumping into a topic that is as complicated as something like gRPC, I didn't want to just kind of just jump in and start talking about this technology without giving people context as to why they should even be thinking about this. So yeah, that was a pretty intentional choice to talk about our story and get people interested in knowing why we chose gRPC.
I think anytime you use a storytelling like that via in a blog or in a personal setting, podcast, video, anything like that, I think it's much more memorable and you can actually understand the reasoning behind a lot of the choices much more. So I wish more people would do storytelling in their presentation. So kudos to you for doing that.
Oh, thank you. That's so nice.
We'll make sure to add a link to your talk in the show notes. Mm-hmm. But before we actually go into the details, there's also another thing that I wanted to talk about. So you said at VSCO, you were starting to like dabble a little with the backend architecture and stuff, right? And specifically, I think you mentioned in the talk that VSCO was using gRPC to communicate between microservices, right? But not actually between the Android app client and your backend. I want to just quickly touch on that before we actually delve into some of the details. So could you talk a little towards that?
Yeah, I can talk about it just a little bit. But basically, in VSCO, most of our backend is composed of microservices that are written in Go. So I guess probably a couple of years ago, we started to use gRPC to communicate between those microservices. And that was really successful for us. It was really fast. It had a lot of benefits. And eventually we decided that we wanted to try bringing that technology to communicate between our mobile clients and our servers. gRPC is very commonly used on the back end, especially with Go, to communicate between services. It's a little bit less common to use it to communicate with the mobile app, but it is designed for that.
Have you worked with Go, like on the back-end stuff?
Yeah. In the past year or two, I've been writing a lot of Go.
Oh, interesting.
You said VSCO started about 5 years back, right? And Go is relatively new, right? Well, compared to most other languages. So were you folks like super early on Go?
So just to clarify, VSCO's been around for longer than 5 years. I started VSCO 5 years ago. Okay. But I think like many other companies, the first version of what we built for our backend is not what we're currently using now. So originally we had sort of a PHP monolith, which is kind of our legacy technology. But over the past couple of years, we've been carving out pieces of it slowly over time into Go microservices.
I wonder if there's any other companies that started with PHP.
Can't imagine that.
The other part from your talk that I thought was really interesting was the in-house analytics that you mentioned, right? So, and the reason I bring this up is because like at Instacart, we actually have a very similar situation, right? So you mentioned in your talk, and folks like who watch your talk will like sort of understand this. You started off with the telemetric sort of solutions. You had third-party services that were taking care of a large part of like these analytics. But then you mentioned, and you didn't actually go into the details, I presume, because of time and like you wanted to get to the gRPC stuff. But you mentioned that VSCO eventually wrote its own service, right, called Cantor. Can you talk a little about why, because I think this is like a very common sort of requirement for most applications that tend to get a little big, just like telemetrics and analytics and all that stuff. At what point did you feel that you needed to write your own service versus just continuing to use the third-party services?
Right. So I guess the main motivator behind that is that VSCO just got kind of large. I think when we were using these third-party services, we were always kind of their biggest client a lot of the time, and it became very, very expensive for us. We wanted to track a lot of events. We wanted to be able to track things like impressions, and using these third-party companies, it became like many digits of expensive. It also didn't really meet our needs as we continued to grow, because we wanted to be able to do machine learning stuff with the data. We wanted to be able to have like an in-house data engineering team and be able to do a lot of sophisticated analysis on our data. And this wasn't really something that was an option for us unless we were building our own solution.
Got it. So your talk obviously talks about gRPC, right? I mean, this might be a stupid question because I haven't actually worked with gRPC and both of you have. So what exactly is gRPC? Is it like a framework? Is it a library? Is it a new protocol? Is it like HTTP2? Is it like something new? Yeah, Sam, maybe you can like kick this off. Like, what exactly is gRPC?
Yeah, for sure. So I think at its core, gRPC is a framework for communicating between a client and a server. So I'm sure many of you who are listening to this are mobile app developers and you're writing your app and you have a server and you need some way for them to communicate. And I guess the solution that you probably most likely have right now is that you communicate using a REST API. So you make use of HTTP verbs like get, post, put, delete, etc. There's like a philosophy behind REST and how to design an API around that. So you might use that, or you might just have sort of an HTTP API that, maybe you haven't put that much thought into, where you have like get and post endpoints. I think a lot of people just make APIs that way. And on your Android client, you probably use Square Retrofit, OKHTTP, something like that to build your HTTP client, and you're probably using JSON or XML also. So gRPC is just a different way of doing the same thing that solves some common problems that people encounter using a more traditional REST or HTTP API.
So I guess gRPC, is it different than REST, or do I call it differently, or how do I interact with it if I'm a developer? What does that look like?
So it is different than REST. It basically uses a network communication protocol called RPC, and the way that this looks is with RPC, you basically call a method, and from your perspective as a client developer, this looks like a normal method, like it's being executed on your phone, but instead this call is actually being executed on a remote server, and the logic behind the networking is sort of abstracted away behind this method. So gRPC is a form of RPC that it was developed by Google and was released publicly in, I think, about 2015, so it's pretty new.
Oh, interesting.
What does RPC stand for?
Remote Procedure Call.
Ah, okay.
I understand REST, right? Like Don said, it's simple to me. Like, okay, HTTP, send a request, a network request. It goes through the HTTP protocol. Something happens on the server, some magic happens, and then like I just get a response. How exactly does RPC differ from that? Like, is it a different sort of mechanism, or is it just some of like the similar sort of concoction of, things?
Right. So under the hood, gRPC and RPC, it's still built on top of HTTP. So under the hood, it's kind of the same things are happening. It's more like a different framework for thinking about how to design an API for the clients and servers to interact. Kind of a different philosophy.
Ah, okay. So that's making more sense. So it's almost like a recommended set of tools that enable communication.
Yeah, sure.
My understanding from RPC, and correct me if I'm wrong, because it's been years since I've worked with it, is it almost looks like you said before, you perfectly said this, in my opinion, is it looks like a method that's just kind of in your project somewhere. You're calling it, you're giving it parameters to, it looks like a regular function call, and then you get some result back. Is that correct? Mm-hmm. So how does that work from an Android perspective? Because I know that a lot of these are, remote. That means it's going somewhere. It's going to go to a remote server. How do I deal with this from a perspective of asynchronous communications? And, let's say on the typical example here is I need to go fetch some data from the server. I'm using gRPC. How am I going to show like a loading dialog or something like that? Am I given these callbacks of something that's happening asynchronously, or what does that look like inside of gRPC and Android?
Yeah. So for Android, gRPC uses OKHTTP under the hood. So it uses something that you're already familiar with. And I guess I can get into talking about what gRPC actually looks like and how you sort of implement this. So the most important part of gRPC is this service definition file. It's called a .proto file. And when you create this file, this is sort of a contract that defines the communication and enforces the communication between the client and the server. So in this file, you can define your entire API. You define the methods that you want to be able to call. You define the inputs and the outputs. It's all right in this one place. And when you compile this file, it will generate code for both the client and the server. So what's great is gRPC supports 10 different languages, obviously including Java, in our case, including Go. So from this file, it'll actually generate all the code you need on both the client and the server for them to communicate. So you don't really have to write in any of this yourself. You don't have to think about like, oh, I have to create this JSON object and I'm not really sure what to put in it to make sure that it's going to have the right fields for the server to be able to parse. You don't really have to do any of that. All of the code is just generated. And so when you're on the Android client, you can just call a method. Like if it's called say hello, you can literally just call this generated method called say hello, and it will just kind of work. And to your question of dealing with concurrency or running this on a background thread, that's also built into the framework for the code generation. You can have it block if you want. I think a lot of people prefer to use like RxJava or something they're familiar with to handle running this on a background thread. But there is also support for just having it be a background process, and it'll just do it.
Let me think about this a little bit. Let's say you say we have a proto file, and that's defining the contract between the person who's going to implement it, or the developer, such as myself, and maybe the server team that has built this gRPC endpoint. Who typically develops this .proto file? Is it going to be the server team, or at least in your experience, is it server team? And as a secondary follow-up question to that, is that same proto file, can that be shared with like the iOS team, and then they can use that same thing to generate stuff for Swift or Objective-C?
Yes, absolutely. So the idea is that this file will be shared between the server and any number of clients that you might have. So in our case, we use the same file for our server, which is written in Go, as well as for our Android client, which is written in Java, and our iOS client, which generates code for Objective-C. So yes, you can use the same file.
Now, I got this file, right? I've gotten it from the server folks, and I want to start consuming it in my Android application. Do I need to have anything installed to generate this, or did the server team already give me the generated files? I'm kind of looking for like, hey, as a new, maybe I just started an Android project and I'm given this proto file. What are my next steps to actually calling this RPC endpoint with this contract?
Right. So I guess there are a lot of ways to do this depending on what your build system is. The way that we have chosen is that we kind of insert the proto into our Android project, this .proto file, and make sure that it's part of the source code. And then we use some Gradle plugins that are already pre-existing. You can look them up. I don't recall the names right now, but we use these Gradle plugins to generate the code. So whenever we run our build, it will take what's in this .proto file, this kind of blueprint for our service and for our protobufs, and it will generate code from it every time we build. And so yes, you need to add some dependencies into your project so that it's able to do this.
Would that be the protobuf-gradle plugin probably?
Yeah, that's it.
Okay. And then once I have that, then at that point, I'm given some, I guess it's probably just dropped into the generated part of my build, or somewhere that the Android build system can recognize actual files that I can use in my project, correct?
Yes, that's it.
Okay. Now I want to kind of take this step a little bit further to kind of bring it full circle just for me so I can solidify this. I've got this pulled down. It's maybe going to pull a list of, let's say, customers. It's RPC. Now you said it can do everything asynchronous for me. Am I given any hooks into that to know, hey, this is processing, hey, it's done processing, or because I am still wondering, like, hey, I want to show this dialogue when something's loading. Do I just fire off this request, or is there a recommended way to do the asynchronous stuff, or no?
Yeah, so if you choose to use the built-in asynchronous support, they do give you callbacks for when it's completed, for when it's successful, and also for when it fails. So you will have that. There might be some more hooks into it, but I haven't played around with them too much.
Oh, okay. All right.
The obvious question, at least for me, given that I've used RxJava a lot before, is like that sounds very similar to like the observables, how like this subscriber, the observers. So is there like an Rx sort of gRPC link to it, or is that something that typically we would have to write?
I think what we've chosen is to use RxJava and to have the gRPC calls just be blocking and to handle it ourselves, which I think is a pretty common solution.
Yeah, I could see it being probably the easiest to implement. I know there are a few other ones out there. I think there's one from Salesforce called, I think, Reactive grpc. We'll find a link, put it in the show notes. And I think I've seen a few others out there. But I completely agree with you that if you're learning this, like just getting going with the blocking calls is so much easier, because then you can just wrap it in whatever. If you're using RxJava, you're going to use, Kotlin's, await stuff. You can use whatever works for you.
Right.
Also, I mean, I can't help but like bring this parallel, right? Because in a recent episode, we just talked about GraphQL. And so when you were talking about the proto sort of file and how it sort of is like a contract, it made me think, oh, wait a minute, what is the difference between like GraphQL and gRPC? Are they competing in some ways, or are they actually different? I'll drop a link in the show notes to this question actually being answered. And it actually says it like in an interesting way, in that, no, they aren't competing, because I think with GraphQL, it's funny, with all these things, it just focuses on one aspect of how the communication happens, right? With GraphQL, apparently, it's just like SQL for your server, right? So how you go about it can be very different.
Yeah.
But with gRPC, and Sam, correct me if I'm wrong, but it's almost like this sort of framework. It's almost a mechanism of efficient communication by avoiding boilerplate. So with this proto file and the generators that he talked about, a lot of this is just built for us in a way where we don't have to necessarily worry about it. Is that a fair sort of summary?
Yeah, I think that sounds about right. I do think that the advantages of gRPC is that it's kind of, it was built with performance in mind, so that it's optimized, and also kind of eliminates the need for writing a lot of this code yourself. It generates a lot of code and makes it really difficult for you to make mistakes in terms of sending the wrong thing between the client and the server, because this contract is enforced by the code. So yeah, I would say that between this and GraphQL, they're solving different sorts of problems.
That makes sense. A large part of how gRPC obviously works, like you mentioned, is like the protocol buffers, right?
So you can't really talk about gRPC without talking about protobufs, which are also by Google and are gRPC's preferred serialization format. So just a really simple way to think about it as a replacement for something like JSON or XML. In theory, they are smaller and faster because they're a binary format, but they're comparable to something that you're already familiar with, which is something like JSON.
That makes sense. And just, to step back for folks who may not necessarily understand this, can you explain the differences between like what a binary format is and what, like, say, something like JSON or XML or some text-related kind of format is?
Right. So I guess really simply, like, JSON is a text-based format, which means that when you have to send it over the wire, there's a process of serializing it. And for something like a protobuf, even though it's kind of, there's a human readable aspect to it, so you can edit it, but it is inherently a binary format. So it's already in a format that can be sent across the wire.
Oh, perfect. So machine code is probably not the exact analogy, but it's something that the machine can more easily read than text, which is something which humans can, that needs to be compiled down to something that machines can read.
Right. And it's also smaller because it's already gone through that process of turning into machine code.
Exactly, yeah.
Interesting. Oh, so is that where like a large part of also the performance gains come? Because over the wire, you're sending something that's like inherently much smaller?
Yeah.
So, and a lot of that has to do with the serialization and deserialization too, because even though it's small, it can be an expensive process, because even if you're putting it on the wire, you're serializing it, deserializing it, as compared to like with a binary format, you're just basically saying, hey, this field here is going to take up this many bytes. This next one is going to come right after it. This is this many bytes long. And the next one is this bytes long, and it's in an exact order. And that's what like the protocol buffer stuff is kind of, that contract is helping state, like, hey, you're going to have these things in this order. And so when it kind of gets down to the wire and gets down to the client, you can, the library at that point can say, hey, I already know that the first 4 bytes are this header, and the next 4 bytes or 8 bytes are going to be this name or whatever. And it can just fly through it. Now, my experience with gRPC is very limited, but I did work with a full binary API at a client years back. And it was a custom binary API they'd written. And when I joined them, I said, well, why are we doing, it's so hard to debug this thing. This is before protobufs was around. Why are we using this binary format? And I said, well, because we can't get it to work with JSON because it's just too slow.
Oh, wow.
And we built a JSON endpoint to test it out, and they were 100% right. It was at least 50 times faster for this binary format, which is basically doing the same thing that protocol buffers is doing, is just reading directly from the stream. which is crazy.
That's insane.
Yeah, and another great thing about protobufs is it works the same way that gRPC does, in which you sort of define a skeleton for what you want the fields that you want the protobuf to contain in the same .proto file where you're writing the service definition for gRPC, and when you compile it, it will generate code that has getters and setters already in whatever languages you're choosing to use. In our case, it would be Java. So again, instead of kind of working with JSON where you have to have all these like hard-coded strings and like you can get them wrong, you can spell things wrong, you can have the wrong things. You kind of have these objects that are generated in your code where you can just use getters and setters, and there's no room for that sort of error.
So in your practical experience, having used gRPC, right? Because many a time, like, yes, that's usually the promise, but is it actually that easy? Like, is the boilerplate actually that simple once you have things set up? Is that something they've noticed as you worked with gRPC?
Yeah, I mean, my honest opinion is yes. I think, we can talk about the downsides of gRPC, and one of them for sure is kind of the setup process and getting your build working and getting your dependencies working out, and kind of just like this first time setup. There was kind of a somewhat high cost to that, but since then, setting up a new endpoint is honestly dead simple. It's just kind of a matter of updating the .proto file and building, and you're kind of just like ready to start using this auto-generated method and this auto-generated request object and this auto-generated response object. It's really, really easy.
Oh, that's crazy. Wait, let me just step back to like make sure we're mentioning. So Sam goes in today and, like she's like, oh, I need to add a new endpoint on the VSCO app. What you're saying is literally once you have the proto file updated, like say the folks in the backend have done what's necessary to expose that endpoint, they would just give you an updated proto file. Mm-hmm. You would update your Android app proto file with those changes, and you're saying you would run the build command and then you just can access that in your activity or like wherever, or your repository if you're being better with your architecture. Is it as simple as that?
Yep, that's as simple as it is. Let's just say the backend team creates an endpoint that we'll call it say hello or something. It has an input that's a hello request proto that maybe has a bunch of strings or bools or whatever. It has a hello response object that has some sort of response that again could be strings or ints or even a list of some sort. And if I copy that proto into the Android app and build it, all of the code for this say hello method will be auto-generated, and I can just call this method. I can populate this hello request object using the builder pattern. They make it kind of easy for you to do that. Populate all of the different parameters that it needs, and I'll just get back this response object that has all the fields I need, and all that code is already generated for me.
I think one of the cool things here, though, too, is that stuff has been done for you, but also your iOS counterparts can then just generate the stuff that's needed for them, and then they're ready to go too.
Exactly. And I talk about this a little bit in my talk, but one of the main reasons why we started using this was because we had a use case where we had built this analytics system, and we were tracking, like, at this point, probably hundreds of different events. Anytime a user does anything within the app, we want to track that, which is something super normal. And because of this, we ran into a lot of problems where the iOS and Android apps were not in sync because we were kind of just relying. I think we had this like big wiki page where we had all the events listed out, and each one had like dozens of different fields of like parameters of things that we wanted to track. And we just found that we'd capitalize things wrong, we'd spell things wrong, we'd forget fields. Maybe the wiki page wouldn't be up to date or something, or the Android team would even add their own fields or something, and it was just kind of impossible to keep them on the same page. So what's really great about this is now the iOS app, the Android app, and the backend are all in this enforced contract of agreement as to what the fields are that they're supposed to be sending up. And instead of having to document this in some sort of wiki page, the proto file is kind of self-documenting. If you want to know what all these fields are, you just look at that, and that's the source of truth.
Oh, this is fantastic. I actually have a bunch of follow-up questions because this is actually a very similar pain point that we had here at Instacart.
Yeah.
So a couple of things. So it's interesting because actually one of the ways we chose to solve this problem, which actually I don't think is as good as having it like this, but it worked, was we had this new library that we built, and internally it's called Events Nirvana. I don't think we've open sourced it yet, but the idea is essentially when you run the compiler, we look to see the events, and this is more like a runtime thing. So when we have the schema that the server generates saying, hey, and it's almost like the wiki, but only obviously like, we wanted the validation to happen in code, right? Or like we wanted the machines to take over the validation. We didn't want like a human like going and cross-checking. So the way we eventually sort of like worked with one of the solutions is that we have this validation schema, and anytime you send up the event, it would try to validate against this schema that we had locally, and then it would throw warnings or errors saying, hey, you really need to update this event because this is not the format that, the server is expecting. So the use case that you mentioned where like, it's capitalized or something like that, we handled it that way. But again, it's very similar. If a large part of this problem is also if you have an existing code base with like, 50 events that are already being sent wrong, in all likelihood, like nobody's going to go back and like fix all of those, right?
Right.
I like your solution way more, like with using gRPC to solve this, because essentially then and correct me if I'm wrong, I imagine like now if I have to like, use the analytics, you would directly call this method, and this method would be something that's defined as part of like the process that we talked about, right? So what you're saying is like the only way to call this method would be to provide the parameters that it expects, and that's how you would enforce that you're getting the right data.
Yes, that's exactly how it works. And it's hilarious that you had this like JSON validator sort of schema, because that's exactly what we used to do also to try and keep consistency between Android and iOS. And I mean, it wasn't the worst solution, but it does mean that you have to keep that updated. Like somebody has to be thinking about that. And it's kind of like, why do that if you can just have one file and have the code enforce it instead of having it be like a people thing?
Oh, absolutely. Yeah, no, that makes 100% sense. I guess my follow-up then is, after you decided, hey, okay, maybe gRPC is like the way to go for this, right? How long did that process take to set up, right? Like I'm thinking, tomorrow I'm going to go to my team and say, hey, this amazing developer I talked to, Sam Bobra, said gRPC is the way to go. Let's start on this. What is a logical time frame to expect? Like how long did it take for like VSCO to like get there?
Right. So I think with gRPC, I think the people who will get the most out of this talk are people who work for companies where gRPC is already part of the stack somewhere, just because I think the cost to getting it set up just solely for the purposes of communicating between the client and the server is a little bit high, because this is something that's going to require a lot of backend and infrastructure work to set up. It might not be supported by the load balancer that you use. The cost is pretty high to integrate this into your stack for the first time. So I would say that's non-trivial. But for us, because we were already using gRPC pretty extensively on our backend, getting it set up was mostly, I think, work on the client side, which was kind of just like getting the build system working, getting all of these different plugins happening, kind of just like figuring out a system for how we were going to make sure that the proto file stays updated. And that was I think it was some amount of work, because I think back then it was not documented super well, but it was a one-time cost, and I think since then it's been working for us pretty well.
And when you say the setup cost, it's not necessarily just the setup costs on the client side, it's also the server side, right? Like enabling your server to have like gRPC, then enabling it to communicate with a client through gRPC, and then obviously enabling gRPC on the Android client itself, right? Or the iOS client, and like multiple clients. Okay.
So yeah, definitely like the infrastructure work of getting gRPC set up on the server is a big part of the battle. But like I said, because it's already pretty common, I think there are a lot of mobile developers who might work for a company where gRPC is already in use in some way or another. It's kind of just a question of extending it to the mobile clients as well.
And when you started off, when the VSCO Android app started off, did gRPC already exist, or was that something that you had to like migrate towards?
Yeah, it definitely did not. I think when we launched the VSCO Android app, it was, I think, 2013. So we were using a traditional HTTP API and using retrofit for that for a really long time. And we still have to use that for our older endpoints, right? Because we still have to support older clients. But I think moving forward, every endpoint that we've written since we started using gRPC has used gRPC. So it's kind of what we're moving towards going forward.
I have a quick question in regards to some of the protocol buffer stuff that we had spoke about before I forget. You said that they actually generates the files that the clients can use. Mm-hmm. Can those generated files be altered at all or no?
Yes, absolutely. So for one thing, there are a couple of different code generation libraries, even for Android, that you can use depending on what your needs are. So I think there's kind of one that's common for Java, sort of like server-side Java. It's just called Java. There's another one called Lite, which I think is the recommended one to use for Android, just because the code that it generates is it's just smaller, like more. It's better for somebody who's worried about something like APK size. And there's one by Square, which is called Wire. So I think the first step is kind of choosing which code generation library you want to use, because there are a lot. But then on top of that, what you can do is write your own code generation plugins, which we've actually done, I think, on both the client and the server side to sort of generate additional methods, like additional code whenever the proto files get generated, which is sort of like, it's a process. It's something that I think our plugins are written in C++, but it's definitely very possible. And especially on the back end, we do a lot of additional code generation, and it's been really cool.
Now, so that's cool. You can write your own generator and do all kinds of cool stuff that way. But now the actual files that are outputted from the generation can you edit those, or should you not edit those at all?
Would not recommend editing those, because every time the code gets generated, it'll just kind of overwrite it. Okay. So that's a no.
Okay, excellent. So this kind of leads me into one of the areas which I've always had a question about, and I've kind of never really been too sure about because I didn't dive into it too much. If you have this protocol buffer file, and let's say this method signature has 2 parameters, and later on I decide I don't need one of those parameters and I need to remove that. Is that something I can do with RPC, or how does that work? Because now the contract seems to be broken for older clients and newer clients. Is that something that you've encountered before, or is this not even an issue at all?
Right. Yeah. So protobufs are designed to be backwards compatible if you kind of follow a couple of rules. I won't get too much into it, but I think for every field, there's kind of a numbered tag. And if you remove something, I think it's okay as long as you kind of just reserve, like, if it's number 2, make sure that nobody creates another field that's also called number 2, where you'll get sort of a conflict. But there is sort of a philosophy behind backwards compatibility, and protobufs are designed so that you won't have those sort of problems if you follow the rules. Okay.
Now, one of the things that it's kind of questioned me as well is, like, all right, is there a way to easily debug this? For example, right now, if I have a JSON REST endpoint and I want to interact with it, I might just fire up like the Postman client, submit some variables, and I'll see the JSON or XML or whatever's coming back, and I'll actually see it right then, and I can interact with my API that way to kind of debug or figure out and kind of just spike out different ideas. Is there anything like that for gRPC, or how do you go about doing that type of thing?
Sure. So I would say that one of the downsides is that there isn't exactly a curl tool, or you can't use curl in the same way that you would for a normal HTTP API. But technically, the way to debug it would be to build something like a small client, which gRPC makes very easy. But I think these days there are a lot of tools that people have come up with to solve this problem. I think I haven't used many of them. I think there's something called like grpc-curl, where people have built like command line tools to solve this problem and let you debug gRPC the same way that you would debug a normal API.
Got it. Another thing that I want to ask as a follow-up from a previous thing, you mentioned, like, interestingly, the name of the library was Java, right? I was like, interesting name.
Yeah.
Is there a Kotlin?
Yeah, so Kotlin isn't officially supported by gRPC or protobufs, but I think like people have attempted to write their their own code generation libraries for a bunch of different languages, including Kotlin, like including Swift. I'd say there's probably not like a strong need to use that because of interoperability and whatnot. But yeah, people have attempted to do things. I'm just not sure how reliable it is.
And at VSCO, you folks use Kotlin a lot, I presume, right? With the existing architecture. So you haven't necessarily found the need to force some things in Java just because of that, because the interop suffices, is what you're saying.
Oh yeah, definitely not. I mean, the generated code is in Java, but we're able to use it really seamlessly in Kotlin files.
Got it. That makes sense. I guess the next question is, do you have an idea of how hard the server-side part of this is? Because a large part of a lot of these client libraries, right? Like, sure, as a client developer, it makes sense to do this, but do you have a sense of how tricky this can be on the server side of things? Like, do your server-side developers like gRPC, or are they like, oh my God, it is such a pain to maintain. I make the life of my client developers easy, but this is not easy. I'm trying to get a sense of how hard it would be to implement gRPC on the server side, because I'm sure that's like something that our like listeners are going to do, right? Like they're going to go back to like their companies and tell their server-side developers, hey, I heard about this cool thing, gRPC. Can you get on that? So the question is like, how hard is that? Like, do you have a sense of that?
Right. Yeah, so I guess I was working on Android at the time when this was implemented on the back end, so I can't speak too much to that, but I can say that server-side engineers in general love gRPC. Like I said, okay. It's a lot more common to use it on the back end. Obviously, Google uses it really heavily. Lots of companies like Netflix, Lyft, lots of other companies. It's very common, and I think in general it is easier and more convenient to set it up on the back end than it is for the client, because it is, it's a lot more common.
That's great then. So you're probably not going to get as much pushback from the server-side developers, is what you're saying.
Right. So, I think back in the day when we first started working with this, it was a lot more difficult to find infrastructure that would support gRPC. But these days, there are a lot of options. I think the common one is we use Envoy by Lyft, which is a load balancer that supports gRPC, and there are a lot of other options out there. So it's easier today than it was.
Oh, and you mentioned this as one of the disadvantages in your talk, right? Mm-hmm. Like, as in, not all of the load balancers are like supported. Not all load balancers support gRPC. Right.
So that's a downside, is that like depending on what your infrastructure is, like it might be easier or harder to get gRPC working. But I would say these days, because it's so commonly used, there have been a lot more solutions than there were in the past.
Got it. And I guess the last follow-up question that I had, at least in terms of this section, was with the generated code stuff. Like, I'm not sure about you folks, but one thing I've noticed is like code generation has made me pretty mad recently. Like, I just feel like, when Kotlin is like upgrading, you have capped with the annotation processing, and you have like some of the other code generation, like with Dagger. Sometimes I find myself like tearing my hair apart, right? Like, because the code generation, something breaks, or like the sequence of something has broken. Is that something that you have noticed with the code generation process here? Because it sounds like with gRPC, especially on Android, there's a lot of code generation that's happening, right?
Mm-hmm. Yeah, it is something that we have struggled with a little bit. I would say that it's not broken. That's kind of not one of the problems we have. Like, it works. It definitely generates the code that it says it's going to generate, and it does that pretty well. But I guess that's another downside, is that if you have specific needs that the generated code is not meeting, that could be an issue. And you can solve that problem by writing your own code generation plugins. Like I said, that's something that we did, because there were some methods that we wanted that didn't already exist as part of the generated code. But that is some extra effort that you have to do. So if you have very specific and complicated needs out of what you want from the generated code, it might not meet the needs.
I think that's fair.
Is there if you were to, I'm trying to think of the best way to say this. Is there a recommended few things that maybe you want to stay away from when you're using gRPC? Like, hey, if you're going to do these 3 or 4 things over here, that's probably not a good use case for gRPC, or is it kind of just all inclusive?
I would not say that there are necessarily things that you should stay away from.
Okay.
I would say that if you don't use gRPC if you don't need it, right? Like if you haven't really had any pain points using a REST API, like if it's working, I would say that this is maybe not something that's worth dedicating a lot of your time and resources into getting set up. So I think that's the only advice I would have is like don't jump into this if it's something that you don't need.
Okay, cool.
In terms of your experience with VSCO, you mentioned like the analytics use case. That was like a very strong use case as to why, oh, this makes perfect sense. Are there any other such use cases? I guess performance would be another one, right? For gRPC that would like sort of, what are the other like advantages through gRPC where it sort of like should make sense for someone to implement gRPC, if that makes sense?
Yeah, so I can talk about one thing that we're also using, which is gRPC supports streaming. So that's kind of, the client can request a stream from the server and then read from the stream until all the messages are complete. And once you open the stream, the server can kind of push messages to the client, right? So we're actually using this, I think maybe not in the Android app yet, but in the iOS app for a messaging and chat functionality that we released about at some point last year. So that was something that would have been pretty difficult, I would say, before we updated to using gRPC. But gRPC makes that really, really easy.
Oh, and a large part of this is basically as part of the HTTP2 protocol that gRPC uses, right?
Exactly, yeah.
Can we quickly touch on some of the things with that, the advantages that HTTP2 provides? Like, obviously, one is like it does binary sort of format pretty easily, right?
Mm-hmm. Yeah, so like everyone knows, HTTP is the underlying protocol for how data is formatted and transmitted across the web. And HTTP2 is a more modern version of HTTP, which I think the best way to describe it is it's kind of like faster and better without you really having to do anything at all.
For free.
Yeah, exactly. It is a binary protocol instead of text-based, and we talked about why that is more efficient and more compact. It also supports multiplexing in a way that means that it can send multiple requests for data in parallel over a single TCP connection instead of having to open a new connection and open another one, which would mean that things could kind of get backed up before. In this case, you can kind of send as many requests as you want over the same connection, which is great.
And the last thing that you mentioned, and this is like really cool, right? So you mentioned this, your iOS client basically does something similar where it sort of has a pull mechanism, right? And this sounds very similar to like what WebSockets essentially allow you to do, right? Where
Yes.
like there is like a two-way communication that's happening.
Yes, and I have worked with WebSockets before in the past, and it's kind of a pain. And the way that gRPC works is so easy. Again, it just kind of generates code for you to start a stream and read from a stream. You can check out the API docs if you want to see what that code looks like. But yeah, they just make it really, really easy to do things that in the past could have been pretty prohibitively difficult.
At this point, are there like any parting thoughts that you want to leave our listeners with like the whole gRPC experiences?
Yeah. So I guess what I would say is I'm not necessarily here to like evangelize the heck out of gRPC. I want to make sure that people have sort of a balanced evaluation of it. So I will say that, yeah, getting it set up is hard. It can be really hard. And that is something that people should take into account. I will also say that it's always hard to do something that's not the common path, right? Like it's a pain. It's not documented as much. You might not find what you need on Stack Overflow. Like it just, it's not something that everyone's
a Google
doing.
Technology not documented enough? No way. That can't be true.
Right.
That can't be true.
And
I got this job.
And especially the fact that it's not something that everyone in the Android community is using. Like there's not consensus on it. There isn't the best information, like for example, about benchmarking. Like this is something that's supposed to be really fast, but like, is it? Like I'm not actually really sure because I haven't benchmarked it for myself.
Right.
So yeah, choosing the less traveled path is always going to be difficult, which is why I would always give the advice that if it's not broken, don't necessarily fix it. Like if what you're doing is working for you, there's kind of no need to to bring yourself into something that's going to possibly create more problems for you. But for us, I think once we got past the initial setup, it's been really, really successful. It makes creating new endpoints super, super easy. And I don't hear a lot of complaints about it from the mobile teams. It was something that people were very wary about at first, but it's kind of working.
Sam Bobra, grpc evangelist, hashtag grpc everywhere. Like those are the words that Sam, this was amazing. Thank you so much for like all of this information. This is definitely something that is very new to me, and I'm sure like our listeners like would appreciate a lot of this. Your talk at DroidconSF was an amazing talk, and I'll make sure to add that in the show notes. What are some other resources that you would suggest for, gRPC?
Okay, if you want to learn more about gRPC, you can definitely check out the official website for it, grpc.io. I would also recommend checking out the grpc-Java repo, which is the Java-specific code generation. You should definitely go read about protobufs, which is also on the Google website, as it's another Google technology. And you can check out the protobuf-gradle-plugin, which is for code generation in your Android app specifically.
Okay, Sam, I'm sure like folks enjoyed this episode a lot, but I'm sure they also have a lot of like questions, or like, they want to ask you more about like specific things, your experiences having used gRPC at VSCO. If they wanted to do that, what would be a good place to do that?
Yeah, so they can shout me out on Twitter. I'm at Sam Writes Code.
Perfect. Sam writes code. And Don, I hear you write code too. What would be a good place to contact you?
The best place for folks to reach me is going to be on Twitter or Instagram and the same handle, and that's just at DonnFelker. Kaushik, what if folks want to see what kind of code you're writing tests for?
Oh, I don't know if you want to see my code, but KaushikGopal on Twitter. That's a good place, and on Instagram. Thank you all so much for listening. Sam, thank you so much for all of this information. This was really interesting. I'm definitely going to go back and bug a bunch of server-side folks today at work and ask them about the gRPC. Yeah, about possibly using gRPC. Thank you so much for this.
No problem. And yeah, huge shout out to my team, the community team at VSCO, to my coworkers Melinda and Joe, and to the VSCO fam in general. This was extremely a group effort. Like gRPC is not the sort of thing that one person can set up and put together. So it was really everyone.
Thank you all for listening. We will catch you in the next episode. Once again, we want to thank our sponsor for today's show, Bitrise. Bitrise is a mobile continuous integration and delivery service for your whole team with dozens of integrations for your favorite services. Head on over to bitrise.io to find out more. Thanks again for sponsoring today's show, Bitrise. That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.